Okay. Um, my brain's still going on what this fiber and I were talking about just now. Okay, this is f of x. I'm sorry I forgot the first few y'all to record, but I'm recording now. And so I'm comparing these three values, 0 to 3. This is just really making sure you understand about negative area under the curve and whatnot. And so when I looked at this, I thought, okay, this is positive, right? So 0 to 2 should be my biggest value. So this one, and I literally above mine I wrote big, medium, negative. So this is the biggest, and then this is going to be negative area, right? And I do have a 2 to 3, so this is going to give me a negative area. And then the whole thing is going to be some positive, some negative, so it kind of lies in the middle of all of them. So it's going to kind of go like this is bigger and this is bigger, right? Unless I reverse the order and put this one first, which they did. So D would be the answer because look at the way the alligator mouth is eating. So it ordered from smallest to biggest. 10 was a doozy for me because of the no calculator part, I think. Okay, let's see. We're going from 0 to 2. All right, so this was a U substitution. And I knew that because I've got to a power of 3 and I've got to a power of 2, one below it here. So if I let U be x cubed plus 1, then du could be 3x squared dx, right? So I need a 3, which means I need a 1/3. I also went ahead and adjusted these bounds since I have a U substitution. So if I put U in here, 2 to the third, so I've got 1/3. 0 would be 1, 2 would be 8, 9. And now I've got U to the 1/2 du. Antiderivative here. So add 1, that'd be 3 over 2, right? Put in the front for 2/3. U to the 3 over 2. And again, I'm going from 1 to 9. Notice this is a 2 on the bottom. These are perfect squares. 2 over 9. Is that plug in what? Yes. To get the new bounds. Then I did 9 to the 3/2 minus 1 to the 3/2. Square root of 9 is 3, and 3 cubed is 27 minus 1. (26) times 2 is 52. And that happens to be A. Because that's, okay, so 9 to the 3 over 2, remember the sunshine? It's the square root of 9 cubed, which is 3 to the third. And then you did the square root. Holy crap. So how did you figure out that it was 27? Oh, I got you. Holy crap. Yeah. It's always the algebra. It's always the algebra. So you said 11? No? I'm only 1 point off. 1 point off on number 11? Yeah, it's not 4. Does anybody need 11? Y'all all got that? Okay, let's do it. I was going to say, this is a differential equation, and this could be kind of hard. All right, x squared plus xy minus 3y equals 3. It said find dy dx at the point 2, 1. So first thing we need to do is just start taking the derivative. Remember, we're taking it with respect to x. So every time we take the derivative of y, we've got to follow it with a dy dx. All right, so you got 2x plus product rule, derivative of the first times the second plus the first times derivative of the second minus 3 dy dx equals 0. Everybody that's got a dy dx can stay. Everybody else got to go. Negative 2x minus y, and now factor out the dy dx. Now I have found dy dx. Now all I have to do, or all I should have to do, is plug in 2x minus y. What was the point? 2, 1. So dy dx at, yeah. You should still get the same answer. Do they? That's fine. That's fine. Negative 4 minus 1 is negative 5 over negative 1. I can't remember what y'all told me you needed me to go up through. 12. 12 asked you for what rate in gallons per minute is the amount of water changing, and it gave you the number of gallons. So it said W of T is 25 minus T squared. So really what they wanted was the derivative at 3. Because if they ask you for rate, they're asking for derivative. So to do this, I did the derivative, and then I just plugged in 3. You didn't have to worry about units or anything else because they didn't ask you that. Some of those are so easy that you second guess yourself because you go, surely that's not what they wanted. But all right, what else? Okay, I thought 13 was hard. So the first thing I looked at with 13 is I know when y equals 4, the slope is always 0. So I went to all the choices. Well, any one of those that you plug in for, so that didn't help me, right? So I kind of started looking, all right, well, when y is, and I couldn't really even tell what that was. We need to look at when something is, let's see. I didn't do this one clearly. I skipped it. Oh, I have a star by this one too. Oh, that's smart. So that eliminated A and C. All right, so now we got it down to between B and D. And honestly, there's quite a few times whenever if you can just eliminate and guess and you got a 50-50 shot, go for it because sometimes that's literally what you have to do. All right, so but I'm gonna go with, did you guess B or did you guess D? Okay, let's think about this. Y squared, that's the key there is the squared. Y is always positive when y is, so let's look at some negative values of y. You see what I'm saying? Because negative squared is going to be positive. So I'm thinking when y is negative, the slope is going to be positive on D, but negative on B, but positive on B. So that's what I need to look at. So if I look at everywhere that y is negative, that's from the x-axis down, all those slopes are positive. Do you see that? So I need to pick a derivative that's always going to give me a positive when y is less. Do you understand what I'm saying? I don't know why I didn't reason through this whenever I did it. Once we eliminated the x's, it's a little bit easier to see, I think. When y is less than 0, right? So when y is negative, that's going to be a negative times a positive, which is going to mean that this whole thing is negative. Here, it's going to be a positive times a positive, which is bigger than 0. So anytime I'm below, anywhere down here when y is smaller, if this is the differential equation, all the slopes will be negative. And if this is the equation, then all the slopes will be positive. Does that make sense? We're fixing to fall asleep on us. I'm sorry. So that's why it's D. That's the best explanation I can give you for slope field on this one. Look for zeros, positives, and negatives. That's what I try to do anyway. Places where those things are always like that. All right, what else? I think it's 14 looks worse than what, no, 13 was bad. I mean, 14 was bad. I just looked at all my work down there. All right, so dy dt. This is one of those things where you'll have probably one question and it be multiple choice on the exam. There's a shortcut for it, but I don't ever feel like it's worth the brain space for the shortcut. I always work it out. K is a constant. That's your clue there. Constant. Time t equals 0. Weight of the population. So initial is 120. Increasing at a rate of 24 grams per day. All right, so here's how I found K first. I said, well, if it's 24 grams per day, and that is at that initial amount at 120, I solved it for K. So now I have dy d, what are we doing? Dy dt. 1/5 times y. Now I can do my separation of variables. So dy equals 1/5 y dt, and I move that y over here. Integrate. Log of y is equal to 1/5 t plus c. I put that initial value in. Remember, it said it was 120 when time was 0. So I said the natural log of 120 equals 1/5 times 0 plus c. Honestly, at this point, I was second guessing myself and thinking, I'm doing this way wrong. This is way too much. But I'm in too deep now. I see where I stopped for just a second on here, but it ended up coming out right. I'm going to leave this in the answer because I'm not sure what's happening, but that's my C value. So I have the log of y, and y is always going to be positive because we're talking about a rate that it's increasing here. It says it's always increasing. All right, so equals 1/5 t plus log 120. Now E it. So this is y equals. Now remember, if I'm adding, that really means e to the 1/5 t times e to the log 120, which is convenient because this is just 120, right? So 120 e to the 1/5 t, which is the same thing as b. Remember, you got an average of 2 minutes per problem. Some of them are quick, like that derivative problem, but some of them like this. You don't want to get too bogged down where you eat up all your time and then you get to the end and you're just bubbling in. So it may help you whenever you get to these to go, you know what, I know that this is going to be a doozy, start and come back to it whenever you come to actually work it. I'm too OCD to do that. I'm not going to lie, I just work through it. What else? 15. All right, so I felt like 15, A and B were easy to eliminate on that one. I mean, because we know that the limit as x goes to 1 on f of x, that graph that does this, we know that the limit there does exist and that it is 0 because from both ways it approaches this. It's just so A was easy to eliminate because it says which of the following statements is false. B was easy to eliminate because it says that it does not exist, and that's correct that it does not exist. You looked at what was right? No, I read it as it does exist. So A and B were eliminated. I thought that it was a pretty difficult thing to decide between C and D because we know that limits can't split up with multiplication like they can with addition and subtraction, right? That's the one property that doesn't work there. So we've got, let me just come here to this one. We've got the limit as x approaches 1 of f of x, e of x plus 1. And we've got the limit as x approaches 1 of f of x plus 1 times g of x. So here's what I did. I said, well, let me try a substitution with this. Okay, so let me plug in. If I plug in 1 here, so f of 1 times g of 2, I'm still not doing the limit. I'm just kind of working inside here. F of 1 I know to be 2. And g of 2, I know to be 1. No, it's asking me if it exists. Never mind, you can't do that. What did I do? I have it written. I have that written under this one, and then I have f of 2, g of 1. Both of these, well, here was my reasoning, and this is probably, I need to go back and research this a little bit, but this is why I chose C. When I looked at this, both of these points, if you look at the graph, both of these points are actually continuous points on the graph defined at those points. Both of these end up being discontinuities on both graphs. So I figured if there was a place, no, because that's saying it's false. Bro, I don't know why I picked C. I'm not gonna lie. I'll go back and look. I did pick C. Tell me, Jalen. What does what mean? Well, and since you're multiplying, this is. How did you know D was right? But he's saying he knew D was correct. Okay, so that was kind of what I did was I said I know f of 2 and g of 1 are points on the actual graph, so the product of them has to have a limit. If each one of them individually has a limit, right? That's just what I thought. C, I couldn't come up with a reason why it did not exist or it did exist. This says it did. Maybe it's because the limit exists on every point in the domain, so it must exist on the product of its domain. I'm not sure. Let me look that one up for you. Jalen, I'll have a better answer for you tomorrow. Okay. I might have to consult on that one with, huh? Yeah, absolutely. What else? Me too.
And I got it wrong. I must have.
But you can't split them up because of the multiplication. I do know that. You can split them up if you're adding or subtracting, but you can't split. Like, this limit does not equal the limit as x goes to 1 of f of x times the limit as x goes to 1 of g of x plus 1. You see what I'm saying? You can't split them like that. Now, if you were adding here, you could do that, but you can't do it whenever you're multiplying. But you're right. There's something. It's a property they're testing, and I can't think of what it is they're trying. The only thing that. What? That's just shifting it to the left one. I'm thinking this is something, if I had to bet, something about limits existing on a domain, then it also exists on the product of the domains or something. It's got to be something like that. I'll look though. I'll look it up. All right, let's look at 16. 16 was, yes, a double sign chart. I'm glad you did it, Avery, even if it was doing it wrong. Oh, you don't need it now? Do need 17 though, okay. Let's see, a particle moves along the x-axis if it is time. So this is giving me position function. I think that y'all probably got help. This one was not hard, but I think you probably got, huh? 17. What's the first time at which the velocity of the particle is 0? So I know I need to do this because that is velocity. I'm gonna put this 12 on the outside. Do product rule, derivative of the first. Don't forget to chain it. Times the second plus the first times derivative of the second. No, he's not in this class. Because he's Mr. CHS. Don't. I tell you what went. I don't even have any words. Nothing. What won you the pageant? The surfboard one? Yeah. Go to class. All right. I want to know when this beast equals 0. That is a beast. Ugh. All right, I took the e to the negative t out whenever I did this. So I said 12e to the negative t times cosine t minus sine t. Yes? Think about zero product property. This is never going to be 0. There's nothing I can plug into t that's going to make that 0. It's not going to impact my answer whatsoever. Here's where you probably went, uh-oh. When does this equal 0? Well, if you just separate them, where does cosine and sine both have the same value? Pi over 4, right? They have the same value. So t equals pi over 4, which is a. That's the first time on the unit circle that they actually equal each other. That one looked a lot worse than it was. But we're definitely getting into the heavy hitters now because we're into the almost to the 20s. What else? 19 and 21? 19, 20, and 21. So we're good on 18. Y'all understood the difference in the big F and the little f and all that? Okay, good. 19. F of x is 2 cosine x plus 1. What is the approximation for f of 1.5 found using the tan line to the graph x equals pi over 2? So the first thing I'm going to do, it says tan line, I need a point and a slope, right? Point would be f of pi over 2. Don't worry about that f of 1.5 yet. That's what I'm going to approximate. First thing I'm going to do is find the point. What's the cosine of pi over 2? 0. All right, so your point is pi over 2, 1. Now I need a slope. The derivative, so derivative of 2 cosine x would be negative 2 sine x. And now derivative at pi over 2. What's the sine of pi over 2? 1, so this is just negative 2. I got a point and a slope, yes? Y minus 1 equals slope times x minus x1. Now it asks me to plug in 1.5. Y minus 1 equals negative 2 times 1.5 minus pi over 2. And at this point I went, my answer is never going to look like theirs. But this is 3 over 2. Negative 3 plus pi. Negative 2 times 3 over 2 is negative 3. Add 1, and that's C. Those are satisfying when you do get them. Yeah. And then you said 20? Okay, 20 was one I eliminated 2, and then I had it down to 2, and I made my best guess on that one because I wasn't 100% sure what that graph looked like without a calculator, right? All right, so I definitely eliminated D. I knew it wasn't a vertical asymptote because of that absolute value. I also eliminated oh, why did I eliminate A? It's not a vertical asymptote, no. Vertical, right, and even though that bottom could equal 0 and I've got a point there that's undefined, that it's just flipping it, essentially, right? Yeah. Well, but here's what I did. It says a removable discontinuity or a jump discontinuity. So what I did just to see is I said, okay, if they're both of those are talking about at the point 2, right? So I found f of 1 and I found f of 3, and somebody might have a better way that they did this. I found this to be negative a half. I found this to be a half. And I was like, oh, that's a jump. That jumped from 1 to 2. That's how I guess jump on that one, is I kind of looked at some values. Anybody do that one a different way? 21. That's smart too. So I kind of did the same thing with some points. I didn't graph them, but I thought, yeah. 21. Ooh, 21 is the alternate definition of a derivative. So if you remember, there's those 2 definitions, and I told you the alternate would come up maybe in one multiple choice question, but not a lot. It's the same thing. We learned the difference quotient, and then we talked about the alternate definition, and I said you could use either one. This is nothing more than the alternate definition here. So if you recognize that that's the alternate definition, then you recognize that all they're doing is asking you to find the derivative at 3. Well, the derivative of log x is 1 over x, so the derivative at 3 is just 1/3. Did anybody get that one? Did y'all? So, all right, the alternate, you know how we got the difference quotient, which is the limit as h approaches 0 of f of x plus h minus f of x over h, right? We also have that alternate definition. That alternate definition says if you're finding the derivative at a specific point, you can do the limit as x approaches a of f of x minus f of a over x minus a. It's just another definition of the derivative. And this is about as far as you, just to be able to recognize it, not that you have to memorize, but that's all they're doing is testing. Do you understand that that's what they're asking? This is difference quotient. This is the alternate definition of derivative. This gives you derivative of f. This gives you derivative of f at point A. Did y'all plug it into that? Log x minus log 3 over x minus 3. Okay. Y'all just get this. Ooh, I have lots of scratchies on number 22. Is that what y'all said, 22? Yes, 22. dy dx, so this was a differential equation. 2y over 2x plus 1. It told me that y of 0 is e when x is bigger than -1/2. So I did. The problem here, whenever you split them up, if you multiply by 2x plus 1, you end up with them. I'll just show you. But multiply both sides by that, both sides by. My variables are mixed up, right? So really this is 1 over 2y dy. Oops, no. Yeah. And 1 over 2x plus 1 dx. And now I integrate. This is one of those U substitution problems, right? Because I got 2y down here. Or think about it like this, and it might be easier here. So this is 1/2 log y. If u is 2x plus 1, du is 2 dx, so I do need a 1/2 out here, log 2x plus 1 plus. I'm going off script here because this is not how I worked it. Okay. Log y equals log 2x plus c. I used that point they gave me, which was 0e. Say again? Yeah, from both sides. I hope this works out because I had log 2y here for some reason. Okay. Log, this becomes log e, which is just 1. They gave that to me in the beginning. So now I have log y equals log 2x plus 1 plus 1. If I e both sides, I get y equals remember, this is like saying this times e to the first. These would cancel. I'd get e times 2x plus 1. And if I distributed that through, I get 2ex plus 1, which is b. Whenever you have that e there like that, yes. That's as far as I made it, so I'm off cuff now. I'm just flying by the seat of my pants, but I'll keep working on. What other do y'all need? $24 and $26. The average, this is 24. The average value of a continuous function on the interval -2 to 4. So average value, -2 to 4 is 12. So let's see, that means 1 over 4 minus -2 times the integral from -2 to 4 of f of x dx equals 12. What? I'm not looking at that. Right now, I'm just looking at the first part before the comma. Because they're saying, if that, then what is this? So let me look at the if part first. So if that's true, all right, so that means that 1 over 4 minus -2 is 6. Integral -2 to 4 f of x dx equals 12. And I'm just kind of working with this because now I'm looking kind of at what they want. They're wanting from -2 to 4 f of x over 8 dx. Well, I know that by properties of integrals, I can say, well, this is 1/8 times the integral here. Agree or disagree? So if I can solve this for just this part and find out what that is, then I can just divide by 8 and have my answer, right? So over here, I get the integral from -2 to 4 of f of x dx. 72. So that means this is 72. Well, what is 1/8 times 72? See. Is that right? You sure? We're definitely not making it to calculator. We never make it to calculator. We're going to do calculator tomorrow. We'll spot through some calculator. All right, how about next? 26. and 25. 25, the figure above shows the graphs of the function f and g. H of x equals f of f times g, then the derivative. So this looks like a straight product rule. And then we're going to use the graph to find those values is what I'm assuming. So derivative here would be derivative of the first times the second plus the first times derivative of the second. And it asked me to find it at 2. Since these are just lines, my derivative is just going to be my slope. So the slope of line F looks like it is up 1 over 2, 1/2. The slope of G looks like it is down 1, 2, over -2. G of 2 is 1. F of 2. Uh-oh, is this one I need to calculate the point on? No, it's a half. 3.5? No. F of 2. Oh, yep. There you go. A half minus 6, -5.5. So D, 11 over 2, -11 over 2. Bless you. No, you're not. Don't say that.
I literally got that, but I don't know why I put my end of my word says 1/2 minus 6.
And you put -1.
I don't know why.
Well, that means you're definitely going up next time because you'll bubble the right answer 65. All right, 26. Limit as, y'all do not like limits. E to the 3x plus x over x. Can I expand this top? No. Okay, I know the bottoms go into infinity. If I take the log of a super huge number, I'm going to be getting, I think I'm in a L'Hopital situation. Did y'all try to L'Hopital it? It didn't work? All right, what happens if I L'Hopital it? 1 over e to the 3x plus x times, chain it, 3e to the 3x. Yes. Oh, those are so close. I'm just trying to do derivative again. I love taught it twice.
The one like at the top.
Right here.
Yeah, if you plug in.
I think so. That's why I love taught it again. That's what I think. Because you'd essentially have infinity plus 1, which is still infinity, over infinity plus infinity, which is still infinity. So I just taught it twice. When in doubt, L'Hopital, especially on limits. And keep L'Hopital. I don't think they'll be okay. How about 27? Good. The graph of the derivative is shown in the figure above. Which of the following statements must be true? And so my derivative looks like this. Does f have to be continuous on AB? So it's like a well, if the derivative is defined on that entire interval, the definition of a derivative is that it has to be continuous, right? So it must be continuous. So part 1 must be right. Part 2 says that the function is decreasing on the open interval. Decreasing would mean that's not true. Think about this is the graph of the derivative. It tells us what the function is doing. So we're looking for everywhere the derivative is 0, and the derivative is 0, it's happening right here. So it's positive and negative. So the function is not always decreasing. The function is only decreasing here. The derivative. And then concave down, well, it has to be because the derivative is always decreasing, so it has to be. So C, 1 and 3. I got time for one more. Maybe. I don't know. I haven't worked these, so maybe not. 30? I probably don't have time the way you said it. I bet I don't. For a certain continuous function f, the right Riemann sum approximation of bleh is bleh. Did y'all get this one?
No.
Yeah, I'm gonna have